Hi! Today we are going to be your teachers and we want to tell you about levers and how they act in our human bodies. First, let's listen to Alex so he can tell us something about muscles and the levers and the history of them.
So I will start by telling you a bit of history concerning the levers. Levers are one of the basic tools that were probably used in prehistoric times. A lever is a simple machine that makes work easier for use. Many of our basic tools use levers, including scissors, pliers, hammer claws, nutcrackers, and tongs. I will continue to tell you about types of muscles in the human body. In skeletal muscles, the common arrangement of the fascicles varies, resulting in muscles with different shapes and functional capabilities. The operation of most skeletal muscles involves the use of a leverage and lever systems, partnerships between the muscular and skeletal systems. So I will show you some examples of muscles. Here is a circular muscle called orbicularis oris. Here is a convergent muscle called pectoralis major. Here is a fusiform muscle called biceps brachii. Here is a parallel muscle called sartorius. Here is a multipennate muscle called deltoid. Here is a bipennate muscle called rectus femoris. And here is a unipennate muscle called extensor digitorium longus.
Is a rigid bar that can rotate on a fixed point that's called fulcrum. Now, we apply a force that's called effort and we try to beat the resistance. And then you can see two arms. The effort arm, that's the distance between where we apply the effort and fulcrum, and the distance between the fulcrum and where the load is applied, or the resistance, is the resistance arm. Now, in our body, what can we say? We can say that the bones are the levers, our joints, they are the fulcrums, our weight, it is the resistance that we try to beat with our contraction of muscles, that's the effort.
First class levers, second class levers, and third class levers.
But for each class of the arms and the ratio of the effort arm and the resistance arm is equal to the ratio of the forces inversed. Okay?
Now I'll show you the first class levers. Here is the active force, and here is the resistance. Now, for class 1 lever, the pivot lies between the effort and the load. A seesaw in a playground is an example of a class 1 lever, where the effort balances the load. The place where your skull meets the top of your spine is a class 1 lever. Your skull is the lever arm here, and and the neck muscles at the back of your skull here provide the force or the effort to balance the load, which is the weight of your skull. When the neck muscles relax, your head nods forward.
For a class 2 lever, the load is between the pivot and the effort. Let me show you. Here is the lever, here is the pivot. We have the load and the effort. An example of a second class lever is found at the lower leg when someone stands on tip-top, over here. The axis is formed by the metatarsorophalangeal joints, and the resistance is the weight of the body, and the force is applied on the heel, like this, by the gastrocnemius and soleus muscles through the Achilles tendon.
Here we have active bar. Bent arm is a class 3 lever. The pivot is at the elbow and the forearm acts as the lever arm.
The biceps muscle provides the effort, force, and bends the forearm against the waist of the forearm in any way that the hand might be holding. The load is farther away from the pivot than the effort. There is no mechanical advantage because the effort is greater than the load. However, this disadvantage is compensated with a larger movement. A small contraction of the biceps produces a large movement of the forearm. This type of lever system also gives us the advantage of a much greater speed of movement. And here we have the forearm.
What Archimedes said about the levers. Give me a lever long enough and a place to stand, and I will move the earth.